Hi everyone. Do a quick video on this rack and pinion. I know there's two other rack and pinions out there. Uh, they were built during the kind of remote period of this class, so they're a little more geared towards like a prototype. They're adequate and they show a lot. They're very informative, but with the materials that are available to us right now, I think we can do a lot better, a little more robust. So I thought it would be fun if I disassembled this and then reassembled it, talking about the components that are real important in how this thing would go together. So why don't I do that? I'm going to start by pulling this apart. So here we go. I'm going to get rid of my base screws. 3 screws for that. So what else holds us on here? These two pieces right here are kind of important. They're idlers, but they're important in setting the overall width of this assembly based on the shaft that's in here. So let's get rid of these. I did loosen some of the screws a little bit earlier just to get this to be a little quicker. And I know Josh is going to be able to edit this pretty good. All right, so now that my rack is all disassembled, let's start putting it back together piece by piece, and you'll see these are all the components that make up this assembly. There's really not that much to it. There are a few important things, of course, like the relationship of the pinion gear to the rack itself, right? That's paramount. That's like number one. And you'll maintain those distances by these side holes right here. This one's for the pinion gear, and this is where the slide assembly is going to sit on. So by doing the calculations, you should be able to get that really nice and make it so that the relationship is loose enough that it'll move fluid, but not so loose that if it sees any load that it will end up binding. So why don't we start by assembling our slide piece. So when you want to make a rack and pinion, right, you have the rack and you need to attach the rack to something. So it's not easy because we can't glue these. Adhesives don't work very well with nylon and any of the acetates, that type of plastic material. So we have to figure a mechanical solution. So what I've decided to do was the aluminum plate that we have would make up a great slide assembly for my rack. So that's what I did. I took some of that material and I cut a groove that would accept the rack. And as you can see, it sits down in this channel and it sticks just high enough above that the teeth of the pinion gear are not going to hit the aluminum. They'll be engaged with the rack itself. So just through a little bit of calculation and math, you'll know how deep to make that. The other thing is adhering the rack to that slot I put in now is also important because the aluminum has a tendency, the nylon has a tendency to, have a flex to it, and you can see that this has quite a bow to it. So I decided what I was going to do was pin the rack right through side by side, and that would go through the slide body and the rack itself, and that would mount it so that it sits nice and flat and parallel to the backside. So that's how I achieved that. So What determined the width of my slide? It's pretty cool because I was trying to think of what I could use for my slide base. What's this going to slide in, right? So I took 2 of the 5/16 bushings and I put them end to end like this. And you can see that that makes a great channel, right? The flanges are bigger than this smaller diameter, so they make a channel for my slide to actually sit in. And being nylon, right, the coefficient of friction is nil. So not only am I captured side by side, but I'm also, I create a nice channeled slot for myself. So I determined where they were going to be, again, by doing the math, and that's the relationship of the pinion to the bottom of the slide, and that determined where these 3 holes were going to be. So why don't I assemble the slide base? So it's pretty straightforward stuff, eh? So I'm going to put 2 in for now because it's easier to put my side piece on that way. I'm not dealing with 3 shafts, I'm only dealing with 2. So now you can see how that creates that channel for my slide to sit in. And there'll be a 3rd one right here. So this might be a good time to actually start assembling the pinion too, now that we have the 2 sides off. So let's go over what this pinion drive looks like. So this is made out of, not counting the bushings, it's made out of 3 components. I have a spacer ring, the actual shaft itself, and the pinion gear. And I used hex because hex won't allow the gear to slip. Once that's engaged, it's not going to be able to go anywhere except the rotation that the motor gives it. So I'm going to put my bushings into my side plate. So that's always bushings, right? And then I'm going to put another one into this side plate. And then we're going to start assembling this guy. So I put a spacer on this side so that when this sits in here like this, it'll keep the side plates equally spaced from the pinion gear from both sides. And it'll keep the gear central to wherever these 2 sides are going to end up. And we'll go over that in a second because there's something else that determines that. So let's put this assembly together. Put that in there. That shaft goes in. Now I'm going to put my slide pieces up. And assemble my sides. So there we go. You can see now my gear is central to this spacing here. And so this doesn't fall apart, I'm going to just loosely put these E-clips back on so my shafts don't have too much room to wiggle around. And here we go. Here's one. Here's another. And while we're doing this, I'll probably put that 3rd one in. So all the while when you're designing these, right, the ultimate thing to keep in mind is that relationship between the pinion gear and the rack itself, right? It's right in the name of the device, rack and pinion. So they're real important that their relationship is such. So I'm going to put my bushings in down here. A little tricky, takes a little dexterity. And there we go. Okay, so now you can see that I have my slide pieces mounted and retained in there. So that in the rack. So that's pretty cool, huh? It's a little janky, right? Because I'm not tied down yet. But you see that relationship right there between the pinion gear and the rack. how important that actually is. And by maintaining, doing the math and figuring out where the bottom of my slide is going to be in relationship to where what they call the pitch line of the rack. That's where the gear is going to sit in the teeth of the rack. And it's pretty simple. Once you do it, you see how when they relate to each other, how the math just kind of comes out at you. All right. So now, in order to make this really robust and work properly where there's not too much play, I decided I was going to join the two sides here and incorporate an idler. And what the idler is nothing more than a shaft that's been threaded on both ends. And there's two of them. There's one down this end and there's one down this end that it's going to determine the parallelism between these two plates, which is important for me because I want this to run true, correct? So that's how I made these. Was I took the smallest gear we had, cut the hub off, drilled the hole to fit my shaft, and made these two spacers. These two spaces are independent, and based on the width that I'm going to need, determined where the spacers were going to be in order to put the idler, which just floats free, in the center of this assembly. So let's put that on. And I think I'll just put these in roughly and just give them a little snug up. So save time. And then I'm going to put this one over here. So you can see now, right, by the length of the two threaded shafts, the one I just put in and the one I'm doing right now, you can see that that length is going to determine, once these are sandwiched together, that length is going to determine the parallelism of my two side pieces, which is important. Not as important as the relationship of the pinion to the rack itself, but I always like to think when I'm building something, everything's important because you never know when one thing affects the other. So it's an approach that's been successful for me in the years that I've done all this, but you'll figure all that stuff out as you proceed through your engineering. So let's put that guy in. All right, so there you go, right? Look at that. Running really well. Nothing's loose. So now I'm just going to put my base piece back on. Oh, another thing about the side pieces here, right? Rather than make it out of one piece of aluminum and try to bend it into a U shape and maintain all those tolerances that we need to maintain, such as the distance between all these holes, I find it easier to make it out of two pieces and make them identical so that when you mount them side by side parallel to each other, the holes all line up. And if you take care in your design to really kind of accommodate those tolerancing, I think you'll find you'll have some pretty good success. So there it is. There's the rack and pinion assembly. I made a little handle for it. Rather than put a motor on it, I decided to go with a handle. So I made this little handle, a couple set screws. Remember, if you ever use set screws, which are horrible to use, but that's what we got, always put a flat on your shaft so that the set screw has a place to sit on. And just give that a little snug up. And here we go. We're off to the races. Nice and smooth. Very robust. Cool. Hopefully that helps.